In this lesson, we're going to continue to look at prime numbers. So, reminding ourselves from the previous lesson, a prime number is a number with only two factors. In addition to that, the two factors must be different. They must be completely separate factors. They can't be the same. So if we look at this first example, complete the list of the first 10 prime numbers. Now again, this idea of 1 comes up. Well, why is 1 not a prime number? Well, 1 can be split into 1 times 1, but the factors are not different. The first prime number is in fact 2, because 2 times 1 is the only factors of 2, but they're different factors. So we've got 2, 3, 5. You can pause this and try it yourself. But 7 will be next. Common mistake is people put 9. They kind of got the odd numbers. In fact, all prime numbers are odd apart from 2. 2 is the only even prime number, but the rest are all odd. The reason they're odd is because if they were even, they would divide by 2 as well as themselves in 1. But anyway, 9 is not a prime number. It divides by 3 as well as 9 and 1. 11, 13, 17, 19, 23, and 29. That's the first 10 prime numbers. And again, if you want to see more than that, then you can look at my last lesson. But prime numbers go on infinitely. They continue. The last lesson I went up to 100, but they continue on forever. Right, okay, question 2. Write out the factors of 12. Okay, so 1 times, I always do it in factor pairs. Again, look back at the factors lesson if you want to look at this. But 2 times 6 will make 12, and 3 times 4 will make 12. So in fact, it's 1, 2, 3, 4, 5, 6 factors of 12, and that's the reason why it's not prime. A prime number only has 2 factors, which must be different. How many factors has 18 got? Well, let's do factor pairs. 1 times 18, 2 times 9, 3 times 6. So it's got 6 factors. Is it prime? No, it's not. Okay, which of these numbers are prime numbers? Well, right, firstly, let's highlight them. So 2 is a prime number. 4, no, that's even. So we're looking for any odd number after this that only divides by itself from 1. So that's not. Yep, 11 is a prime number. 14 is even. This divides by 5. 31 is a prime number. 47 is a prime number. 51 actually divides by 3. Again, you can check that. 5 add 1 makes 6. And 6 divides by 3. So if you do that technique, add the individual digits, and if the answer divides by 3, then so does the number. And 67 is also a prime number. They're all prime numbers in that list. Okay, right, so bad joke time. All prime numbers apart from 2 are odd. What does this make 2? The oddest prime number. Of course it's not odd, but yes. Right, let's try this wee thing. I bet you I can guess what your answer is. So prime number puzzle. Choose any prime number bigger than 3, any one you want. Square it, which means multiply it by itself. You can try this. Add on 5. And then divide your answer by 8 and try and remember the remainder you have. Okay, and this works for any prime number you can choose bigger than 3. Now, without me knowing what you did in your head, bet you your remainder's 6. Now, why don't you go and try and work out why that worked? I'll leave that you to think about that one. Right, finally, I'm going to look at a thing called composite numbers. So composite numbers are basically any numbers that are not prime. So any number that's not in the list of prime numbers is called a composite number. There's more composite numbers than obviously prime numbers. Now, the definition of a composite number is a number that can be formed multiplying other numbers, or formed is like composed, which is where the word composite is coming from. So composed, a number that's composed of other numbers is why it's not prime, basically. Okay, so here's an example. Which of these numbers are composite numbers? So I'm looking for numbers that are not prime numbers. So that's a prime number, so is that. That's not a prime number, that's not a prime number, neither's that. 23 is. That's not a prime number, neither's that, neither's that. That would be 5 times 11, that's not a prime number, and 61 is a prime number. So these are the composite numbers, the ones I've highlighted there.